In this video, we figure out at any time t after launch, where is a projectile? The x position will have changed by some amount, the y position will have changed by some amount, and by what amounts will those change? Right here. The x position will have changed by this amount, right there. The y position will have changed by this amount, right here. The y position will have changed by the amount given by that equation. These changes, along with the initial x and y positions, tell you where the projectile is at the time t. Let's show you that. Here we have an object that's launched from the ground with an initial velocity that's given. There's the angle, and we want its location relative to its starting point at that time after launch. Not when it's at the top, not when it lands, that particular time. We want to know where it is. Whenever we have a projectile that's launched at an angle, the first thing we do is we sketch out the initial vectors. 35.58 meters per second, and the angle is 55.8 degrees. So we're going to find Vx, and we're going to find Vy initial. And when we do that, we're going to use sine and cosine, as always. So I'll show my work here. Vx is going to be the hypotenuse, which is 35.58, times, check out the triangle, the cosine of 55.8. And when we do that, that's going to come out to be 20 meters per second, Vx. Vy is going to be the hypotenuse times the sine of 55.8, and that comes out to be 29.43 meters per second. The 20 meters per second is horizontal. The 29.43 is vertical. I'm going to write those into the sketch right here. As always, whenever we are dealing with up and down motion, we need to choose a convention. And so I'm going to choose upward to be positive, which means this 29.43 is a positive number. But what else does it mean? It means that AY, the acceleration, is going to be negative, because that vector points towards the Earth. What are we supposed to do? Whenever we want to know where something is, we've got to use those two equations. The x position will change by this much. The y position will change by that much. Let's do the x one first. dx is equal to vx multiplied by time. Vx is 20 meters per second. The time is 2.43. We were given that. We didn't have to calculate the time. I think that might be the first time that we've never had to calculate the time. 48.6 meters that way. That's how far horizontally it's moved by that time right there. What about the vertical position? dy is equal to, here's the equation again, Vy initial times time plus 1/2 Ay times time squared. Vy initial is positive 29.43. The time is 2.43. All right, here you go. This is, if I had $1 for every time I've seen students mess up this next part, I would not have to teach anymore. And it's this 29.43. Look at the arrow that I'm pointing at over here on the left side of the screen. You see how it points up? And we chose upward to be positive. But the acceleration due to gravity is pulling in this direction, which means this AY, let me put a triple underline under it, is negative. Ooh, there you go. So this quantity here is going to come out to be a positive number. This quantity right here comes out to be a negative number. There is a subtractive effect due to gravity. And when you do that, in fact, I'll go ahead and write these numbers out. This one comes out to be 71.515 meters, and this quantity comes out to be negative 28.964 meters. So, how high above the ground are these golf clubs after we have launched them 42.6 meters upwards? That's where they are. They've moved over to the right 48.6 meters, and they're this high above the ground at that instant of time. Let's do another one. Now we have something launched horizontally. So there it is. Vx is 36 meters per second from a height of 92 meters. So there's 92 meters right there. And we want to find its location 3.24 seconds after launch. So that's the time right there. Once again, as always, we need to choose a direction up or down to be positive. And because this is launched horizontally and any vertical motion will be in the downward direction, I'm going to simplify things a little bit. I'm going to say that downward is positive. If downward is positive, what does that mean? It means that AY, which points downward, is going to be positive 9.81 meters per second squared. Vy initial is 0 because this is a horizontally launched projectile. So in the up and down direction, initially it has no velocity. And what do we need to do here? What did it say? Way back when we started, to find out where something is at a particular time, you got to use that equation in the x direction and this one in the y direction. Let's do it. Dx equals Vx times time, 36 meters per second times 3.24 seconds. I'm looking at sig figs and it looks to me like there are 2 sig figs. So I think that's going to come out to be 120 meters. In 3.24 seconds, that cannonball has moved 120 meters to the right. What about dy? We have to use this equation. Vy initial times time plus 1/2 ay time squared. Vy initial we said was 0, so that term goes away. 1/2. Now, for this case, we said downward is positive, so 9.81 is positive. In the previous problem, we said that upward was positive, and so the 9.81 was negative. But here, we defined it as downward being positive. And we can do that. 3.24, square that. When you type that in, you get 51.5, roughly. 51.49 meters. Now, what does that mean? That's how far downward it's fallen from its original height. See where I'm drawing this in the paper? That's how far downward it's fallen. So you could say, and let's round to 2 significant figures, 51 meters down, 51 meters below the 51 meters below the original height. That's one way you could say it. Or, since it started at 92 meters above the ground and it's fallen 51, you could say it's still 41 meters above the ground. That would be an equivalent way of saying it. In other words, it's moved. If that's 92, then 120 is about right there. So that's how far it's moved to the right. And it's more than halfway down. So at 3.24 seconds, it's about right there. That's where it is.